Okay, domain and range. So domain is just where our x values exist in a function. X values exist in a function, and then range will be y values of the same thing. Okay, so this is getting on our elevator, and then this is driving our car. Alright, so we did do most of these in class. I'll just go through the first one again quickly. So a pizza company charges $10 for plain pizza plus 50 cents per topping. We don't know how many toppings we have. We know that Allison doesn't want to spend more than $13, so we're going to set the whole thing equal to 13. Then we're going to solve for our x. However, solving for our x does not tell us the domain of the function. It's simply telling us the maximum number of toppings we can have. Okay, so let's solve for x. So subtract 10 from both sides. It's going to leave me with 50 cents. 50 cents times the number of toppings equals $3. So that's going to mean that the number of toppings I can have is 6 toppings. Okay, so this means that I can at most have 6 toppings. Now, if I'm going to buy a pizza, I'm already spending $10, but I don't need to get any toppings. So I can have anywhere from 0 to 6 toppings, right? And now if we think about what that means that in my x place, right, my x values are related to my domain. So I can have anywhere from 0 toppings to 6 toppings. So my domain of my function, domain, is going to be from 0 to 6 toppings. That's it. So you can solve for the second one on your own. Now let's look at this one. What is the domain of the function? So now if we think back to our algebra skills and all these other fun algebraic relationships that we need to make, we're looking at the domain of the function. So if I think about division, right now this is giving me a division problem. I can never divide by 0. If I divide by 0, I get an undefined term and it doesn't work, so I can't divide by 0. Thinking about that means that anytime this bottom piece equals 0, I am going to have something that doesn't exist in my function. So the first thing I'm going to do is I'm going to take that bottom piece and I'm going to set it equal to 0. So I've got 3x plus 4 equals 0. Now I'm going to solve for what my x is, because that x is related to my domain, which is what the problem is asking for. So subtract 4 from both sides is going to leave me with 3x is equal to negative 4. Divide by 3, so x is negative 4 over 3. Great. So that means that any other number that I plug in here is going to give me a valid number, and if it gives me a number, anything besides 0, I can divide by it and my function exists. Alright, so that means that this is important. If I put this in my graphing calculator, my function looks like this. And it gives me asymptotes. Okay. So an asymptote, if you think about splitting a half in half in half in half in half, you're never going to wind up with 0. And that's essentially what an asymptote is. It's just getting closer and closer and closer and closer to a number, but never actually getting to that number. So that is what this negative 4/3 is. This negative 4/3 is an asymptote. Now, if we think about the domain of the function, that means that if I get in a car and drive, because I'm looking at domain is x, so I'm coming across my x-axis. Get in a car and I start driving. Where do I come from? Well, I'm coming from negative infinity. Alright, so that means that my domain is coming from negative infinity. It's important that you use a parenthesis and not a bracket, because negative infinity is not a number that exists on this chart. It's just coming from here, but I never actually get to negative infinity, so that's why I'm using parentheses. Anyway, coming from negative infinity, and I get closer and closer and closer and closer to negative 4/3, but I never actually reach negative 4/3, because if I do, then I have an undefined function. So I'm getting closer and closer to negative 4/3, but never get there. However, then my graph picks back up again, and I pick back up again at almost negative 4/3. So I'm going to put this union sign, and that's just a fancy way of saying and. So I pick back up at my function at negative 4/3, and then I'm going to keep going forevermore, ever and ever and ever and ever, all the way to positive infinity. So there's my domain, of this function. You can solve for this one now. Okay, let's look at this next one. We're going to think about the same thing. So if I think about taking the square root of a number, I can take the square root of any number from 0 on. So that means that I want this inside to be 0 or more, greater than 0, right? My range is going to be 0 or more. So I'm going to come in here and I'm going to take the inside of my square root and I'm going to set it equal to 0 just like I did up here, so that I have 3x minus 5 equals 0. And now I'm going to solve for what my x value is. That's my starting point of my domain, since that's what I'm looking for. So I can start at whatever this x value is, and then I'm going to, alright, we're going to keep going. So let's add 5 to both sides. That leaves me 3x equals 5. X is equal to 5/3. Great. So if I plug this into a calculator, my graph is going to look like this. That means that if I get in a car, where do I get in my car? Well, I'm getting in my car at 5/3. Where am I going in my car? I'm going forevermore in positive infinity direction, and that's my domain. So now you can solve for this one on your own. Great. On to the next page. Okay, we spent a really long time on these, and I'm pretty sure that you guys are not going to remember any of it. Anyway, let's look at this function. So I need to find the domain, the range, the amplitude, the period, and then I need to write an equation. Okay, domain. Where do I get in my car? Well, it looks like it's going on forever and ever and ever and ever, up and down. So I'm coming from negative infinity and I'm going to positive infinity. Where do I get on my elevator? I get on my elevator at -3. And it's a bracket because I touched -3. Get on my elevator at -3 and I go all the way up to +3. That's my range. Amplitude. To find my amplitude, I'm going to take my top value, I'm going to take my bottom value. Top value, which is 3, plus my bottom value, which is -3, and divide by 2. That leaves me with 0. That's this line right here. Then I'm going to take my top value, which is +3, and subtract out 0. And that's going to leave me with 3. That means that my amplitude is 3. Period. Okay, if you think back to when we need to write an equation, we've got two equations. We've got y equals a sine bx minus h plus k. And then we've got y equals a cosine bx minus h plus k. Alright, so to find my period, I need to see how long my function lasts. So if I start here at 0, I'm going to go up, come down, and finish right here. Where do I finish? I finish at pi over 2. So my period is going to be pi over 2. Just like that. Now, to solve for my b value, we know that period is equal to 2 pi over b. And right here I see that my period is pi over 2. So I can set 2 pi over b equal to pi over 2. And then I can solve for b. And I'm going to cross multiply. So that gives me 4 pi equals b pi. Divide by pi. That means that my b value is 4. Great. Okay, now the last thing that we need to look at is, where do I start? Well, if I look here at my 0 point, I'm starting not at my amplitude, but I'm starting at my 0. So this is going to be a sine function. When we think back, cosine always started at our amplitude and then went wherever it was going. Okay, so I know that this is going to be a sine graph, and I can just go and plug everything in. H is our phase shift, and K is our vertical shift. Okay, well, this function isn't moving left or right or up and down, so we're not even going to worry about H or K. Look at my equation, plug in the numbers that I know. So I know that y equals a, which is my amplitude. I know that I've got a sine function here, and I know that my b value is 4. And there is my equation. Alright, and then the last thing that you guys are going to do is this right here. This is totally a calculator problem. Because I don't have a calculator in front of my face, I'm not going to do it. I'm just going to tell you what to do. All you're going to do is you're going to go to your y equals. You're going to plug this in. Your graph is going to look like this. You're going to find what this point is. That's where I get on my elevator. And I'm going to take whatever this point is. Whatever this point is, I'm going to call it a question mark. I'm going to take it from question mark all the way up to positive infinity. And that's all my range is going to be. So you should be able to do both of these totally calculator problems. Great.